human civilization. But this is just the first stage of a much bigger plan. We must continue to search out more worlds, traveling ever deeper and faster into the Milky Way. One day, a cosmic event is going to hit the Earth so hard, it will wipe out every human on the planet. If we're going to live more indefinitely into the future, human beings are going to have to leave planet Earth. Our only hope is to build a space ark that will take us to new worlds around distant stars.
Life is fragile, and that's why I believe we should be at least a two-planet species.
The first target was by far the easiest. It took 42 years for our space ark to reach Proxima Centauri using fusion-powered engines. But now, the ark must move on to find even more distant worlds. The crew can be held in suspended animation, but they'll still deteriorate with each passing year. We need to go faster, closer to the speed of light. But there's a small problem: the laws of physics.
What Albert Einstein figured out is that if you start traveling near the speed of light, things get a little bizarre. As you get near the speed of light, your mass increases, meaning that you have to have more energy to keep you going. When you get to near the speed of light, all the fuel turns into increasing the mass. So all the fuel that before would have increased the speed a lot doesn't increase the speed at all, it just increases the mass. Eventually, you don't speed up at all. You just get heavier and heavier as you shoot out propellant.
Physics won't allow us to travel through space at speed. But there's a loophole that may allow us to cut through hyperspace and reach distant planets a whole lot faster.
Einstein showed us that space itself can expand faster than the speed of light. Space and time is not nothing. There's a substance to it, a fabric, if you will. And you can stretch it, and you can bend it.
In science fiction, galactic travelers manipulate the fabric of space-time using warp drives, crossing the cosmos in minutes, not millennia.
Imagine you're in a room and there's a carpet, and you need to get to the other side of the room. One thing you can do is you can take the carpet and fold it up and bring it all the way close to you, then step over the folded carpet and then let it unfold behind you, and now you've moved across the room really quickly.
It'll take a colossal amount of energy to warp all the space between you and your destination. Physics says the warp drive is possible if you only work the space surrounding the ship.
So we know that space expands, but space can also contract. So if you have a ship and you contract space in front of you and expand space behind you, you can create a warp bubble, and it's been theoretically shown that you can move to up to 10 times the speed of light.
This new generation warp drive creates a wave in space-time that travels faster than the speed of light, carrying the ship along with it, like a surfer riding a wave. Mathematicians have looked at the numbers, and a new generation warp drive would work on paper. Now, NASA wants to get it to work in the lab.
Is it impossible or is it plausible? I think we're in that category of starting to think about, we've got some plausibilities here. Let's go see if we can't do some scientific efforts and see validation of the math and physics.
Harold White is planning a future experiment to see if he can warp space on a microscopic scale. He hopes to concentrate energy into a single point in space and then measure the progress of laser light crossing it. If the light completes the journey faster than normal, he'll have succeeded in warping space-time.
Everybody always asks me about when is this going to be ready to bolt onto a spacecraft, and there's a lot of science we need to do first.
We're only just now starting to look into this. We don't know if it's going to work or not. We might as well figure it out. If it does, boom. And if it doesn't, well, we've learned something interesting about math and science and the way the universe works.
The warp drive would fire us to Proxima Centauri in just 5 months. And to the 50 stars beyond in just a few years. But that's still just our galactic backyard. A warp trip to the far side of the Milky Way will take 10,000 years. And a trip beyond it to the closest galaxies, hundreds of thousands of years. On the scale of the universe, even a warp drive seems pathetically slow.
Within the speed of light is to drill a hole